VHP is Vanessa Hangen in Breslin. We're about a 1,700 person engineering, planning, technology firm. 31 offices up and down the East Coast. There's the commercial for the company. So I run the technology services portion of the company, and we have a very large safety practice that does a lot of work for US DOT. So it actually kind of fits into this project. Why did we get involved in this project? When our safety team learned of the challenge that was there, we actually got a group of our technology and safety team together to sit down and talk about, what are the problems that are out there that could be solved. You've heard a lot about vehicular crashes and that the area we decided to focus on was more on the pedestrian and bicycle side of things. So 2018, there were about 7,000 fatalities in that area. And when you talk to local government agencies, the challenge they have is these things are happening, they don't know why they're happening, and they don't know what to do and how to visualize the potential solutions that existed. So our concept was, could we take a bunch of different technologies that are out there, combine them into a software product that could actually help those decision makers make better decisions and decide where to spend their limited funding that they had. So what we focused on is using data analytics to analyze the data that was going on, geospatial technology to actually map and analyze it from a spatial standpoint to see where they are, and then visualization technology to give them the way to see what the current conditions are and then actually what the potential solutions to those problems were. So that is what My Street actually is. It's that combination of those technologies so that they could actually see safety issues that exist. But we also took a unique perspective is we wanted to also look at it not only from the decision makers, but also look at it from the standpoint of the pedestrians. So what do they see? What are the different characters of a pedestrian? Why do they do what they do and why do they behave the way they are? And can we actually apply that to solve the problem? So what My Street is it's a sketch level planning tool. So it's got to be easy to use. It's got to be cost effective for them to use. We had to readily use data that was readily available out there. We didn't want to have to create a lot of data, but we wanted to provide the ability to upload your own data and bring it into the system as well. In the end, we wanted reports that could come out of it. So creating a customized PSAP or pedestrian safety action plan is a report that defines this is what the current condition is, this is what you could do to improve it, and this is what the potential benefit would be that would come out of that. So make it simple for folks, both the decision makers and citizens, to understand that. And we wanted to take a systemic analysis approach. I'll talk about that a little bit more. We're really highlighting on the person-based risks, so understanding the different characters that exist, and we presented them as avatars in the product itself to understand what is actually going on. So it's basically a 5-step process that you work through in the product itself, the way it works. So the first step is to upload data. So we've preloaded in street data, traffic volume data, pedestrian data that's available on a national and a state-by-state basis. But we also know that local jurisdictions and other ones have data that's more current and more accurate that they want to be able to upload. So we built a suite of wizards and published data models so they could look at those and walk through those steps to map their data into our data model. So it would work so that they didn't have to spend a lot of time forming the data as it came into the system. After it comes into the system and it's in our data model, we can run the analysis that's there. Similar to what you heard from the other presenters here, there are a number of different predictive methods you could use. Those analyses are run, and it presents those by the facility type. So the characteristics, is it a rural road, an urban road, 2-lane, 4-lane, divided highway, those different characteristics, and comes up with plots that show you the top facility types that you need to address. Once you have those facilities types, you could then select potential solutions. So you could do a site level analysis. So as the other presenters described, drilling down into a hotspot, looking at a particular intersection or a leg of a freeway or another area, can we look at what the cause of that is, analyze that site, and then come up with potential countermeasures that could actually solve that problem? Then what we do is we help the user prioritize those solutions. So the avatar concept we have is we have a group of people that we could see how it would affect the health of those users. So we could see that certain situations might be more difficult for certain types of avatars, whereas other ones might need a different type of a treatment to solve that problem. So can we actually look at that health and prioritize the solutions? And in the end, can we actually take action on that and develop a plan and a report of what to do next? So if I back up a second and talk just a little bit more about some of what's happening behind the scenes here, that the systemic approach that we have, it analyzes both the available public data as well as the supplied crash data, takes into account roadway characteristics, traffic volume data, pedestrian count data, and actually helps summarize those crashes and what we think the most likely cause of those are. After we summarize those and the characteristics of those, just the pedestrian crashes, we could identify the factors that are actually causing that. So using some machine learning technology, as described by others, we're able to actually apply those algorithms to the problems to come up with potential solutions. We perform network screening on it and identify the high priority locations and the potential solutions that could be taken from that. After we do that, we also have added in socioeconomic data into it, so census data that's available, so we can look at the surroundings of that area and see the folks that might be affected and sort of quantify that as the amount of people that might benefit from a solution that's provided in that area. So as I said, we've used this approach of the avatar approach, so that the current product that we built has 4 avatars that are in it. The first one is Mia. She's a 9-year-old, loves to walk to school, go to the park and places. She obviously would behave quite different than Michael would behave, who needs a wheelchair due to mobility constraints that he has. So each of these different avatars has different characteristics. They have strengths, like Mia is healthy and active, but also limitations. She's short, she's 9 years old. That's there, so she's harder for drivers to see. So treatments that you might put in place might actually have a different effect if you were that or a 6'5", adult male that could be seen easier moving around. That's there. They also have needs. Mia likes ice cream, so she wants to be able to get there quickly and might not behave all the traffic laws that are out there and signals that are there. And there's also speed factors with each of the individuals. So we basically built these 4 different avatars to start so we could look at the characteristics of how they would be affected. And then we added in the sort of the visualization component of this. So we have a library of different renderings that you could look at. So as you put and describe the characteristics through a wizard of the situation, it will pick the most close rendering that we have available so that you could actually see the situation that you're trying to model. It then allows you to pick different things that are present. Are there sidewalks present? Aren't there sidewalks? Is it near a school or is it not? And based on that, it actually ranks the health of a crossing. So if Mia was trying to cross the street to get to the school at the other side, you could see this could be very challenging to her. That's there. So she's graded as a red in her difficulty of getting across the road. Then we do some of the same things that were described earlier here of looking and sorting through the clearinghouse, figuring out what the best countermeasures were to solve the issue that exists here. And then as you select the countermeasures, you could actually see a visualization of those countermeasures and what they actually mean. So people can see those in a rendering, understand what they are, but then more importantly on the right, you could actually see the effect that they're having at the 4 different avatars that we have here. So if I kind of go back, you could see that everybody was either yellow or red in the first one. We apply the countermeasures here and you can see everybody's gone green. So this is a good potential solution for this particular issue that we're addressing. So we built out a base product now that deals with that. It has a library of about 50 different situations that are there, but has some limitations in the predictive methods. So some of our future enhancements we're going to be doing is expanding the predictive methods. The other big area, as you heard about earlier, is we're working with Verizon and GM and a number of different companies that are actually providing out data that either their vehicles or their cell phones are actually be able to get more accurate pedestrian count data than what you typically have available to work with, so we could do better predictive analytics. We know we need to expand the number of avatars. The 4 we have doesn't cover all of the typical ones that you would have, so we're expanding those out. And then expanding the renderings. There's obviously more than 50 options of what different situations could look like. But ultimately our goal with this is to actually have the ability to go take an actual site photo and use your own photo of your own location, put that in. We've been doing testing with a number of different machine learning techniques where we could actually extract assets from the photo so we could see whether sidewalks are there, signals are there, and actually build the database out of the photo that's there, and then be able to put your treatments on top of your own photo so you could actually visualize the reality of what you want to see is what's going to happen in my situation. So what I will do now is just show you.
VHB is passionate about improving pedestrian safety. Our team works with agencies across the U.S. to analyze crash data, identify risk factors, and develop improvement plans. VHB developed MyStreet as a tool to go beyond the faceless metrics and visuals traditionally used in highway safety. MyStreet focuses on the most critical aspect. We are saving the lives of people, real people, with families, friends, coworkers, and classmates. MyStreet is an evidence-based tool to help the decision maker see safety improvements from the pedestrian's perspective. It uses a systematic approach to safety to help practitioners identify locations, prioritize improvements, and share the results with the community. MyStreet addresses vulnerable system users, such as pedestrians, through a Discover Insight tool to provide the opportunity for state and local leaders to see the potential impact of decisions through the eyes of those it will benefit. While the tool benefits the public, it is intended for use by transportation officials and operators.
People react really strongly to seeing tangible changes, and that's why the evolution of technology now has become so incredibly important for us to be able to communicate what it is that we're trying to accomplish. So if you can start to create a more interactive, a stronger visual database for people to be able to see and develop a better spatial understanding, then you have a better opportunity to communicate effectively what it is you're trying to accomplish.
MyStreet is a free tool that is easy for agency staff to use, requiring little to no prior experience. Users upload their own roadway inventory and crash data in an easy-to-use portal. MyStreet combines this data with social economic data and identifies risk factors for pedestrian crashes in the user's own area through a systematic analysis. The user reviews priority locations, inputting additional site information to help inform their decision-making.
A tool like MyStreet provides a really unique opportunity for innovation for NCDOT to consider options for improvement, understand where locations for safety improvements could make the most difference and correspond to the types of crashes that are happening, and really test the kinds of investments that could be made relative to their cost and to the improvement for the different users we anticipate seeing in those locations.
MyStreet incorporates 4 avatars that encourage the decision maker to consider the wide range of pedestrian capabilities. The user selects different countermeasures for each priority location, and the tool displays how the countermeasure would look at a location with the site's basic characteristics. The impact of the countermeasures is communicated to the user through the avatar's overall health scores. The scores reflect the avatar's ability to safely cross the road, access schools and parks, and improve their mobility. MyStreet produces a sketch-level plan for addressing pedestrian safety and implementing countermeasures. This draft plan can be shared with other policymakers to take action and improve pedestrian safety. The tool can be shared with the public to demonstrate how pedestrians will benefit from the countermeasures through the improvement in health scores.
What's so powerful about this tool is that it embeds data and infrastructure to ultimately find a solution. And what this does is give communities a real-time visualization of how they're going to impact the health and well-being of our citizens. A tool such as this can significantly improve the life expectancy and the well-being during that life of our citizens. Number one, by making them safer, but also by making them more active, all right? So if we can create an environment where people feel safe, they're gonna be more active, and if they're gonna be more active, they're gonna be healthier.
MyStreet will help to decrease pedestrian fatalities and increase walkable communities. By viewing all locations, risks, and countermeasures through the eyes of pedestrians, MyStreet humanizes safety challenges and helps determine implementable solutions. We're all pedestrians.
Great. Well, thank you. And I guess I tried to catch us back up. I went a little faster than I thought to do that, so.
So from the perspective of DOT, US DOT, so we're looking for something original, but also something that can be used. So how do we see what we saw here as something that can actually be used? For example, some of these are proprietary. How do you deal with the data? What's the next step? How do you take what we saw and then put it down to make it actually usable to the end users? What are the next steps? What's the thinking there? It's not just only for the DOT, but also for the participants of their vision.
In this. Yep. Sure, I'll answer for myself and then let you folks answer on yours. But from the standpoint of My Street, all the data that we're using in it, we actually, part of the design was to make sure it was publicly available data. We did not want to use commercially available data. We actually have the ability to host the system ourselves through an environment that we have. So our plan was to make this freely available for folks so that they could use it. They could bring their own data and additional data. That's actually where we see monetizing things in the future, is having the ability to add more features to the product than what it currently has. We would get paid to do that, but then those would be provided onto the whole audience of folks that are using the product down the street. So we've built it in a software as a service model, so it's basically one product that is used by all, and we enhance it based on what the community is looking for.
Yeah, so I can just add on from the Ford perspective a bit. I mean, we had a similar question when we were speaking, but so it's very, very similar to the answer you just heard. So, you know, the intention, we're still figuring out all of the details, but the intention is to have multiple versions of the product, a free or low-cost version that would be available sort of for anyone, just kind of plug and play, sign up, and it's ready to go. All the data is, you know, freely available, public type of data. And then a paid version with more premium functionality where you can have some of the additional data sets and things like that to provide more rich insight, where there's, you know, a much higher cost on our end as well to build out and maintain some of those more premium features. So we're still figuring out kind of all those details. And actually, we're pretty excited about the funding opportunity that the US DOT has coming up as a way to kind of test some of those assumptions around how do we expand the tool. Right now, as I mentioned, it's focused on a specific area within Michigan. What does it look like to bring it to new areas, and how can we kind of learn through that process? So that's kind of our thinking.
All right, so since I'm the only government employee in the teams, I am not looking for profit, to be honest with you. I mean, most of the data, I would say 90% of the data that we are using is already public data. We get it from access from Florida DOT. We augmented with some other data that is also mostly free. Most of the algorithms have been developed and published already, so I mean, I cannot commercialize it anyway. It is only maybe, you know, putting the system together and the AI part that selects, you know, the different solutions, etc., that is not either published or, but, you know, I'm not looking for profit. I mean, as I said, I mean, if I, and honestly, I say it very, very truly. I'm not trying to make, you know, if I save one life, then I was, you know, I was successful, and my students the same. So, but we can continue, of course, to maintain it. We can. It's a platform that we can add data to it. We can add other analytics to it. So it needs maintenance. So I would say, you know, the cost. I mean, we need, like, you know, one engineer to maintain it and upgrade it. Okay, then the cost of this engineer, but we're not looking for profit, basically.
I'll say quickly from the DOT perspective, why we got into this challenge is to bring some non-traditional folks together. And you saw from the 5 semi-finalists, we had an insurance company, an automobile manufacturer, a civil engineering firm, a university, and you know, a ride-sharing company that all came together, very, very different than your typical DOT stakeholders and partners. So that was a huge success, and they all have slightly different business models. And as Jordan mentioned, and as Cal mentioned, we're going out with the next step here, doing NOFO to do see who would like to pilot these, take it to the next level. That'll be coming out in the next couple weeks. And the department's also retained some licenses for the work so that we can continue to develop them ourselves. All right, I think we have time for maybe one more question. All right, well, this is a very exciting project, really exciting concept, how we approached it from the challenge, and just getting more than just a visual out, getting some tools out. So thank you, and let's thank the panel one more time.